What is 25 Creedmoor? We're going to answer that question in this series, starting with a PRS style rifle build. Gavin here from UltimateReloader.com. I'm really excited to kick off this 25 Creedmoor content series, and in this video, we're going to do a rifle build. I'm going to show kind of a high-level overview of building a PRS style rifle for 25 Creedmoor, and we're even going to go out to the range to see how this rifle does towards the end. Let me walk through the different parts and pieces and tools that are going to be specific to this build, and then we'll get on the lathe and do some machining. Okay, so at its core, we've got the Terminus Zeus action. This is a premium tactical style action with a 3-lug design and some interesting features that we'll get into when we talk about putting the rifle together. I've got a Bart line. This is going to be 24-inch finished length 5R rifling barrel in 25 caliber. 1-in-7 twist, cut rifling, stainless steel. The Zeus actually uses a special 3-lug design for the bolt, and so we have a 3-lug action wrench. Because we have this integral rail, we have the integral lug, we can't use a standard Remington 700 style action wrench. This is a custom action, and as is typical, you're going to need some special tools to put things together. I have this bag of bullets over here. This is one of the motivations for the whole project. Blackjack carries a lot of these components and parts. Specifically, they have their own specialty 25 caliber bullets for PRS style applications, and 25 Creedmoor is one of the sweet spot calibers for these 25 caliber bullets. 25 Creedmoor is basically a 25 caliber version of the Creedmoor cartridges. 6mm Creedmoor is a little smaller in diameter, 6.5mm is a little bit larger in diameter, and it helps to split the differences in the trade-offs between the two, barrel life and recoil being two of those. Now we'll get into 25 Creedmoor in a lot more depth after I've had some trigger time and some experience with this firsthand, but I wanted to give you all kind of the high level there. I've got a TriggerTech Diamond trigger here. This has become one of my absolute favorites. I'm running it on my 6-dasher rifle. You just saw the build a few months back. That's my most accurate rifle to date, and I have the trigger set at about 7 ounces. I like a nice light trigger when I'm doing extreme accuracy testing. For the chambering, we're going to be using a JGS Precision 25 Creedmoor chambering reamer. I've had really good luck with JGS Precision. I used their reamer for the 6mm Creedmoor build that I did. I dubbed it 6 Creed UR because I had a custom freebore spec for that. And I have a couple different bushings here because this uses the interchangeable pilot bushing design. The stock. This is the Foundation Genesis 2. The Foundation is a very, very interesting stock because it's not a traditional carbon fiber, it's not wood, and it's got its own unique properties. This stock is made from a material called micarta, and micarta is very machinable, it's very homogeneous, it's very consistent in its properties, and it also has different recoil absorbing characteristics. I've talked to a lot of different people that are running these in PRS, and they say that it's basically like shooting nothing else. So I'm very curious to see how this is going to compare to something like the Manners stock that I used for the 6-dasher build, where we had an aluminum mini chassis inside a carbon stock design. I'm using a Hawkins Precision bottom metal. This is top quality hardware. I talked to the team at Foundation and they said, yeah, Hawkins Precision does an absolutely outstanding job. So what we're going to have here when we're done is going to be a PRS style high precision rifle. I didn't show you this. I've actually got a real nice Foundation full length ARCA rail here. I've switched over to the ARCA system for just about everything because it's so convenient and so stable and so fine tunable. So those are sort of the core components for the build. Next, we're going to get into the process of machining and chambering this rifle barrel. So I just finished the build. Things went absolutely flawless. I was really, really happy with the process, really, really happy with the result. I took a look with my Hawkeye bore scope at the throat area, had perfectly cut rifling transitions, absolutely even all the way around. All that extra work to dial in the barrel to a high level of precision really paid off. I'm using the JGS floating reamer holder in the Precision Matthews PM1440 GT lathe. I've got a complete overview video that has an in-depth overview of all the features, the precision tests that I ran through with it. I've been really happy with it, and I did a confirmation of my level before I started, because if your lathe is not perfectly level, as in consistent level between the tailstock and the headstock end, you're not going to get the precision that you need. And the floating reamer holder is just more of a precaution. With this level of alignment, I can actually use a fixed holder for the reamer, and I've done that with the Grattan reamer holder. I like the way this one works in the lathe, and if I do happen to have any issues, it can help compensate for some of that. The interchangeable bushing that was pre-installed on the reamer from JGS was spot on, so I didn't have to even swap the bushings, even though I had one down and one up in the size range from that. And I'm using Forster go and no go gauges. I only used the go gauge, and I'll get into that in just a little bit. So as promised, I wanted to walk through some of the features with this Terminus Zeus action that are things that you need to consider and think about when you go ahead and do a rifle build, and then also just give you some more information. So this is a premium 3-lug tactical style action with 60-degree bolt throw. Some people prefer 60 degrees. It can be a little bit quicker, which is nice. It has set screw locations on either side if you're doing a switch barrel application. And actually, if you download the tenon diagram, the print for that, it gives you different values for crush for a hands-tightened switch barrel or for a permanently installed barrel like I did here. I torqued this down to 90 foot-pounds. Has different implications on crush, which is going to change how long you cut the tenon to accordingly. So the Terminus Zeus is DLC, so it's got the diamond-like coating on both the bolt and the receiver body. It's got the integral 20 MOA rail, the integral recoil lug, and it's a Remington 700 footprint. It's a semi-clone. So you're going to have compatibility with stocks, and you're going to have compatibility with triggers, which is always a plus. When we go to install the trigger, I'll show you one of the unique features here, and that's the threaded trigger pins, something that I haven't seen on any other action. So this action is also designed for pre-fit barrels, and that means that the internal dimensions are going to guarantee headspace consistency within 1/1000th of an inch. And one of the gunsmiths that's done a bunch of pre-fit work for this relayed the information that they've seen consistency of basically half that, so about 1/2 of an inch. All of the actions that they've tested have been within that tolerance. So I ended up planning the build with this print that Terminus has that you can download for the Zeus action, and I shortened my end play just a little bit. So instead of cutting the tenon to 725 thousandths of an inch, I had it at 728 thousandths of an inch. So I was accounting for about 10 thousandths end play between the end of the tenon and the bolt, whereas they have 15 thousandths of bolt nose clearance. I measured the action, measured all the different parameters there, and calculated that. There's no counterbore when you go to do your barrel job. That is a lot like the Atlas Tactical from Kelbley's that I put together for the 300 PRC. This is a similar semi-clone design, but this action uses 16 threads per inch, where a lot of the other custom actions use 18 threads per inch. A few different things. Also, you'll notice if you look at the reamer print, you're going to see a lug bearing surface. There's an unthreaded area that's held at full diameter, and that is a mechanical interface between the receiver body and that portion. So what I did is I cut a threaded relief in the middle and then threaded the tenon, which I'll get to in just a moment, as we walk through the start to finish process of chambering and machining this barrel. So the process I used on this build for the barrel work is essentially the same process that I've been continually refining, and was originally based on Gordy Gritter's precision rifle building class, and before that, his DVD that he put out with Grizzly. Also, I've been working through the Fred Zeglin series of books. This book here, which is called Chambering Rifles for Accuracy, was co-authored between Fred Zeglin and Gordy Gritters. In Gordy's section here, I have a little bookmarker here you can see there, and I kind of follow along his process, and I have kind of my own modifications. So anyways, if you click on the link to the article in the video description, I'll have more information about the complete series of gunsmithing books from Fred Zeglin. And I'll also note that he runs a company called 4D Reamer Rentals. If you want to have a rifle built or build it yourself, but you don't want to buy reamers, you don't want to wait, you can rent them. You can have them arrive in the mail from Fred, use it, and then send it back. It's a great way to shorten the lead time and to save a little bit of cash. Okay, so what I am going to do is just walk through my own personal checklist. This is right here on the print diagram. I started with a cutoff on the breech end. I like to cut off about an inch of the barrel shank on that end. I used my bandsaw. You can also part it on the lathe. I just find it's a little bit faster for me and more convenient to start by cutting it on the bandsaw and then facing it. And once it was faced on the lathe, I dialed both ends to about a thousandth of an inch and then did a pre-drill. Now the pre-drill, what you want to do is take the shoulder diameter from the reamer, and I actually printed out the SAMI specification document for 6mm Creedmoor, just so that I would have that dimension. The shoulder dimension is going to be the same for all of the Creedmoors, the outer edge of the shoulder. You want to take that and subtract at least 30 thousandths and do your pre-drill at that diameter. And to stop, I like to stop about 200 thousandths short of where the shoulder area will be in the finished chamber. I like to have a little bit of extra room. Now when we pre-drill, we can get the nose of the dial test indicator into where the chamber area will be so that it can reach into where the throat area is. Having the throat aligned very well to the axis of the spindle of the lathe is critical to get a really good chamber job. When that bullet enters the rifling, you want it to enter perfectly square and completely concentric with the shell casing. And if you don't, you could have some accuracy issues, that kind of thing. So that's kind of where I sort of hyper focus when I'm dialing in a barrel. When I get it down to about 1/10,000th of an inch or 2/10,000ths of an inch of run out with respect to the lathe spindle, I know I'm ready to go from there. Now we can bore that pre-drilled area true, because that pre-drilled area is going to kind of guide the reamer in, and if it's not perfectly true, then we're going to start cutting there with a bit of wobble or a little bit of run out, I guess you could say. So I was very, very careful to take a couple light boring bar passes in that pre-drilled area and then check it with a dial test indicator, a 10th indicator, to make sure I'm running real nice. You'll see a little bit of surface roughness from that boring pass. If it's 1 or 2/10,000ths of an inch of jitter, that's not bad. But if the needle is swinging as you're revolving it, then you know you've got more run out to take out. So now barrel is aligned, the pre-drill is bored true. Now it's time to turn down the tenon. And I used the value from the print to turn it down to, it's basically 1 1/16" that you turn it down to. It says 1.062, 1.0625 would be a full 1 1/16", plus 0 minus a half. So when I was happy with that value, I cut my thread relief, and you want, the print here says that you leave 0.2 to 0.25 inches unthreaded. So I kind of was in between the two values there. I used a grooving tool to take off about 81 thousandths of an inch. That's going to be roughly where the troughs of the threads are going to be after they're cut. and that gave me the room to come over for each successive threading pass and have a place to stop, withdraw the tool, and start the process again. I'm using my custom threading depth stop that I have mounted to the saddle. It's a very simple device. It just has a bolt that's held against the cross slide, and the cross slide bumps up against it. And what I do is I have it so that it bumps, and then you apply a little bit of torque to bring down that last couple 10,000ths of an inch to 0 every time. The cross slide comes to 0 every time, and I infeed with the compound a certain number of thousandths of an inch each time. In that way, with that compound set over at 29 degrees, we're able to cut mostly on the advancing edge, but to also clean up that side edge in the direction more or less that we're infeeding. So I made some successive passes there. Sometimes I like to use digital calipers on an existing threaded tenon to get a rough idea of the depth. You just have to make sure you're lined up on the same helical pathway there, and that will get you fairly close. When you get up to that point where you're ready to start taking final passes, you want to thread the action onto the threads. At first it'll turn just a little bit, then it'll turn a whole thread, then you'll have multiple revolutions, and you can stop with whatever thread fit you're comfortable with. With this action, we've got that lug bearing surface, so that's going to provide some alignment. Some people like to run their threads a little bit tighter, some like to run them a little bit looser. Ultimately, the threads should align themselves as the action is torqued down onto the barrel. So I was happy with the fit there. After that, I cut the tenon to its final length. Mine ended up being 728 thousandths of an inch. Put a little chamfer on the edge of the threads. I like to do that with a file, personally, at about a 45-degree angle. And at this point, you're ready to start thinking about the chambering job itself. And for the chambering, I start with about a 1 to 200 thousandths cut, and then I right away measure for run out on that reamed portion of where the chamber will be. If you get a little bit of chatter, a little bit of run out, it's something that you're going to want to investigate. I was very vigilant to check run out during the course of the chambering job because this is a 5R barrel and I've got a 6 flute reamer. And that can be a recipe for chatter. If it is, there's a number of things you can do. Gordy goes over those in his class, including boring away the lands in the throat area before you cut the chamber, so there's nothing there to set up a harmonic or any kind of run out on the front of the reamer. I just took it very slowly and very cautiously. I started with 200 thousandths of an inch plunges because I've already taken away the bulk of the material. It doesn't cut a whole lot at first. And then when I saw the reamer flutes pack up a little bit more, I pull them off with a rag each time and I blow out the portion of the chamber that's being cut to get the chips away. I always monitor how hard is it to withdraw the reamer and what percentage of the flutes are packed with chips. You don't want to get them so packed that things start to score the walls, especially with a shallow taper like what the Creedmoor cartridges have. Now I ran the action up onto the barrel with the go gauge in place and got a rough reading on the gap between the shoulder of the barrel and the shoulder of the receiver. And that told me how far I had to go. I then did some quick math to figure out what my stick out was on the go gauge out the end of the tenon, and that allowed me to work my way up. I actually wrote those numbers down, and as I was cutting successively, I added up the plunge for each one to make sure that I wasn't going to overshoot. That is the last thing you want to do is overshoot. So I got down to the point where I had 2 thousandths of an inch to go. And I know from previous experience, if I go by feel, start up the lathe, I need to cut about 1,000th of an inch, or maybe even a little bit less, just to account for the float and the tooling and all the various things for the take up of that gap. That will end up cutting a little bit more than I anticipate. And what I did to check the headspace, crush is specified at 2 thousandths of an inch by Terminus. So I used the Gordy Gritter's trick and put a piece of Scotch tape on the back of the go gauge. That extends it exactly 2/1000ths of an inch. So I cut the chamber so that the bolt handle would barely go down on the go gauge with 2/1000ths of tape on the back. And you hope that when you assemble the rifle that your headspace is going to land accordingly. Okay, so that, after a little bit of polishing and chamfering for the entrance of the chamber, wrapped up the barrel work, looked really good, everything fit really good, and then I threaded the muzzle for 5/8 24. Now I had enough barrel blank, as you can see here, to go to about 27 inches, but I wanted to go 24 because I have a 6 Creed rifle and I have a 6.5 Creed rifle that are both 24. So it felt like if we're going to compare the ballistics, which we will, and compare the performance, I definitely wanted to go 24. Plus, I intend to use a suppressor. 24 inches is a great overall barrel length for that versatility, not giving up too much performance, but having something that is going to be kind of maneuverable and suppressor friendly. So if you do want to see more detail about that muzzle threading, I did essentially the same muzzle threading job I did with the 224 Valkyrie Remington 700 bolt action rifle build. I went through it in depth and in detail. If you click through to the article, I'll have a link to that other article and you can watch the video or read up on that. So overall, spot on job. I can't wait to see how this Bartline barrel shoots. Next, what we're going to talk about is the remaining assembly steps to put this rifle together. The first step in assembling the rifle is to torque the action down onto the barrel. And if you're like me, this is where I get just a little bit of butterflies. Will the headspace land correctly? Question mark. So I'm using the Ultimate Reloader bench system with a Brownells barrel vise. This barrel vise uses interchangeable bushings for different barrel shank diameters. I'm using 1.25 inch here because I've got an 1.25 inch barrel shank. Tightened things down, screwed the action onto the threads. I'm using the TW25B grease. This is really good stuff. It prevents galling. And I used the Terminus 3-lug action wrench. This is that special tool I mentioned at the beginning of the video with a snap-on torque wrench that's 90 foot-pounds. Torqued it down, and what I did was I just left that Scotch tape on the back of this go gauge. Now it's a plus 2/1000ths of an inch no-go gauge. So I installed that in the bolt, ran it forward, tried to put the handle down. It would not go down. Step 1, success. I then peeled the masking tape off the back of the go gauge. Now it's really a go gauge. Installed it in the bolt, put the bolt forward, dropped the handle, and it went down nice and smooth. Success. This means that with the go gauge installed, we've got the appropriate clearance. That's what we want to see. But with just 2/1000ths extra, the bolt won't go down. What's significant about that is normally a go gauge and a no-go gauge have about 4/1000ths of an inch or so difference. We are within 2/1000ths of an inch, so we've got an even more precise control here over headspace, and that just means less slop, but we are going to know that we're going to be compatible with standard brass shoulder dimensions, that kind of thing. Now it's time to install the Trigger Tech Diamond for the Remington 700. We've already got that trigger out of the package, and this is where we get into one of the unique features of the Terminus action. And that's the fact that with a 5/64 Allen screwdriver, we can remove these pins. This is the first time I've tried this. And so that's nice because we don't have to use a punch. We should be able to, I'm going to actually take the bolt out for this. Should be able to just drop things in and go. Okay, make sure I can see a good visual there. Wow, that is pretty nice. I like that. It, to an extent, negates the need for having a trigger hanger system, which is pretty nice. Okay, I'll just do a medium level of torque on that. Now that was a fast trigger install. I just set the trigger down to 7 ounces, which is where I wanted it to be. And that means our barrel to action is complete with install and complete with configuration. I'm going to take a thread protector here that I custom built for that 224 Valkyrie I mentioned earlier, just to keep the threads protected. An Area 419 Hellfire is in the works for that. Hawkins Precision bottom add-on. This is a really nice piece of gear. Look at how precisely that fits and how nice that fits. It just goes right in. Like, fits absolutely like a glove. And it also comes with these pillars in case we had a custom install of some sort, but we don't need those for this particular install. So I'm just gonna flip this over, and I actually like to insert the barrel to action vertically myself. Be very careful with guiding the trigger through, getting the recoil lug lined up, give it a little bit of a set, and then I'm going to rotate it to make sure, actually that's perfectly aligned already. Insert the action screws, and those are now ready for torquing. Be careful with our screw thread engagement. There we go. Got the front in, the rear in. Okay. Now with things essentially hand tight, I'm going to give it another nice set. And then as I'm torquing, I'm going to feel for barrel movement, and that feels solid. Okay, so we're going to incrementally torque these, and I like to leave my front with a little bit more torque than the rear. It should be good to go. Now we've got a generic AICS magazine. Actually, it's not generic, it's KRG. It's a rebranded AICS magazine. That is one good looking rifle. Let's do a quick dry fire. Yeah, we don't have any ammo in there. I don't even have 25 Creedmoor ammo here in the shop yet. Oh, very nice. Check the safety. Good to go on the safety, and excellent. So, you know what that means. We are ready to mount an optic. So I got the Athlon Cronus 4.5 to 29 by 56 scope installed. Initially I tried low rings. They were too low with this large 56mm objective. So medium rings worked out really well. I'm using the Athlon Precision Machines rings for that. I torqued the rings to the rail at 65 inch-pounds and then the ring caps at 18 inch-pounds, and also installed a bubble level at the same time. There will be a separate story going in much more depth on this Cronus optic. Seems to pair really well with the rifle. We've got a nice 1/8 inch gap between the barrel and the objective, which is perfect. Now I'm going to try for the very first time the Area 419 Hellfire muzzle brake. And there's a couple things about this system that are interesting and noteworthy. I'm going to validate this after some experience. First is its self-timing, in that you don't have to cut the back of the brake or cut special shims and washers, that kind of thing, to time it correctly. It times based on how the brake attaches to this adapter here that has a taper on it. So it can essentially be clocked in any position that you need. And the second is it can be removed and reinstalled without shifting point of impact. So I'm very, very curious to try that out. I'm going to put a little bit of TW25B grease on here, and we'll go ahead and thread on the adapter. Really nice fit. I think I cut those muzzle threads perfectly. We've got a 5/8 inch wrench here, and I'm just going to snug that up a little bit. That profile looks pretty dang good with the really large diameter I have on the barrel here at the muzzle. Okay, now the other thing to note here is that it's left-hand threaded, meaning that it won't self-loosen. And I'm just going to take a quick look. We've got things level here, so I should be able to just do an initial timing here. That's right, I got to remember, I'm going the other way. That's it. It's on there. So I really like that, and I think that looks really, really nice with the rifle. We've got a good complement of kind of the wood look with the micarta. We've got the black, we've got the stainless. I cannot wait to shoot this rifle, and that's what we're gonna do next. So I'm up here at the Ultimate Reloader 100-yard shooting range. We had a break in the weather, which is great. It's been raining. I just got the rifle bore sighted, and we're ready to take that very first shot. We're gonna go for the center of the target here, see if we're even on paper. Oh, nice recoil, but it doesn't look like, oh, there we are. We are on the paper, lower left. After I took that first shot, I thought to myself, yes. First thing was, I was on paper, 8.5 by 11, piece of paper on the lower right edge after my initial bore sight. But what I really couldn't believe was how the rifle felt when that shot went off. This is a 131 grain bullet, and this is less recoil than I've got with my 6-dasher. How could that be? Well, this Hellfire muzzle brake is absolutely amazing. I'll say that. And then the other thing is the foundation stock really does feel different. It feels very dead with the recoil. It absorbs it tremendously well, and it's got a good amount of mass as well. I was using my custom Delrin bag rider and the Sinclair rest with a leather rear bag. The entire setup, of course, with the Trigger Tech Diamond Remington 700 trigger set at 7 ounces. Wow, what a sweet shooting rifle. Totally amazing. But this was really about breaking in the rifle. This was 1 shot clean, 1 shot clean, 1 shot clean, then 3 shots clean, 3 shots clean, 3 shots clean, and then the same with a couple 5 shots groups. I shot a total of 19 rounds, and this ammunition was something that I had to improvise from start to finish. First off, I had to find the appropriate load data for the components I had. The Blackjack 131 grain bullets, and I decided to start with H4350. And what I found was a load, use at your own risk. The 131 Blackjack, 37.5 grains of H4350, Federal small rifle primer, and 2.8 inches cartridge overall length. Really the goal is get some brass formed, because I'm going to take one of the fired cases and make a modified case so that I can get my 2 lands jump and start to work on load data. I didn't have 25 Creedmoor brass. Now Alpha Munitions makes 25 Creedmoor brass. So I took what I had on hand. I had some nice 6mm Creedmoor brass from Starline, and I used an expander ball from a Redding die that I had for 25-45 sharps, screwed into, I think it was a 6.5 Creedmoor die. So not the most elegant way to punch up the case neck to 25 caliber, but it's what I had on hand. I did measure the run out, and I was seeing probably 5 thousandths of run out at the neck. So again, this is just get it done ammunition. I used a Wilson chamber type cedar 6.5 Creedmoor. Not recommended again. Why? 2 things. One is the seating stem is oversized, so it's not going to land on the right portion of the bullet. And the second is it's got a neck area for a 6.5 Creedmoor in the chamber in there, and we've got something that's smaller than that. So again, I measured the bullet run out. I was at probably plus or minus 5 thousandths of an inch, which, considering what I had to reload with here, was not bad at all. Now I'm going to be getting, bushing type dies and the appropriate seating stems. I'm going to be dialing everything in, but for now this is what I had to work with. I noticed my powder charge was a bit light, so I increased it about 4 grains and shot the best group of the day during break-in towards dusk in medium winds. 5 shots landed in a 1/2 inch, and that makes me wonder what this rifle will be capable of with proper components and some low development. I'm very, very impressed with how the rifle shoots and how it feels. It's just incredibly stable, and the Cronus 4.5 to 29 scope is incredibly clear. Can't wait to shoot more with this combination. So this concludes the first part of the journey with 25 Creedmoor. The rifle went together incredibly well. I think this is going to be a tremendous shooter once we do our load development and we experiment with some different components and get everything completely settled in. Here's what I would like to know is, what do you think? If you're a PRS shooter, would you shoot 25 Creedmoor to get that trade-off of extended barrel life and reasonable recoil. What are you shooting that's similar to this rifle? Please drop a comment and we'll start a discussion. Also, make sure you're subscribed with notifications because I've got a lot more 25 Creedmoor content coming up and a lot more other related content as well. Now, down in that video description, you'll find a few things. The first link will be a link to an article that'll have more information, links to product pages, and so on and so forth. You'll also find I'm on Patreon, and I've got Ultimate Reloader shirts at the Ultimate Reloader store. Thank you for watching. Until next time, happy shooting and happy reloading.